All right, today we're going to open up the Programmer's Toolkit and get our hands on the most fundamental tools that make our code actually do something. I'm talking about operators. Seriously, think of them as the verbs of programming. They're the action words that bring all our data to life. You ever stop and wonder how your apps just know things? How does a game know you finally leveled up? Or how does your phone know your password is correct, but when your friend tries, it says, no way? It really seems like magic, doesn't it? But behind every single one of those decisions is a super simple logical instruction.
And the secret to all of it is this shared language, and it's built on these simple little symbols we call operators. They are the absolute bedrock, the fundamental building blocks for every logical decision a program ever makes. And the core idea? It's incredibly simple. Let's take 2 plus 2. The plus sign, that's the operator. It's the tool that's doing the work. The numbers, the 2s, those are the operands. That's the stuff being worked on. And that's really it. That's the fundamental relationship. An operator takes action on operands. And this is why they're just so critical. Trying to write code without operators, it's like trying to be a carpenter without any tools. I mean, you could have all the lumber in the world, but you've got no way to cut it or join it or shape it into anything useful. So let's start with the most familiar tools in the box, shall we? These are the arithmetic operators that basically turn Python into a super-powered calculator. Yep, these are the classics, the ones you remember from math class: plus, minus, times, and divide. Python handles all this basic math exactly like you'd expect. And this right here, this is the foundation for everything else we're going to talk about. But look, basic math is really just the beginning. Python's toolkit has some really specialized operators that are incredibly powerful for us programmers, and they let us solve much more interesting problems. First up is this guy, the modulus operator. It looks like a percent sign. All it does, and this is super useful, is give you the remainder after a division. It's perfect for answering questions like, hey, is this number even or odd? Or just what's left over?
So for example, take 11% 3. Think about it. 3 goes into 11 3 times, right? That gets you to 9. And what's the amount left over, the remainder? It's 2. That's all the modulus operator gives you, that leftover value. Okay, next is floor division, and you spot this one by the 2 slashes. Just think of the word floor in its name. It does a division, and then it rounds the answer down to the nearest whole number, completely dropping any decimal part. It always goes down to the floor. For instance, if you did a regular division of 14 by 3, you'd get something like 4.66. But with floor division, Python just throws away that decimal and gives you the whole number, 4. It never rounds up, it just goes straight down to the floor. Okay, so we've done some math. That's cool, but the real power of programming, where it all comes alive, is in making decisions. So now we're going to look at the operators that let us ask Python questions and actually get answers back. And these are our comparison operators. Now, the big one to watch out for here is the double equal sign. We use that to check if two things are equal, which is totally different from the single equal sign we use to assign a value. Each of these operators here asks a question, and the only possible answers are true or false. So, what happens when just one question isn't enough? To log into a website, you need the right username and the right password. So how do you check both of those things at the exact same time? Well, for that, we use logical operators. And here's the best way to think about them. Think of and as mandatory, like you need your passport and your ticket to get on the plane. Both have to be true. Now think of or as optional. You can pay with cash or a card. Only one of those needs to be true. That simple little short part makes really complex logic so much easier to understand. All right, so now we can do math and we can ask questions. Let's look at the operators that help us manage and work with all of our data in a really efficient way. So we already know the basic assignment operator, right? The single equal sign. It just puts a value into a variable. But to be more efficient, Python gives us these awesome shortcuts. So instead of writing out the long version, x equals x plus 2, we can use the shorthand x plus equals 2. It does the exact same thing, adds 2 to whatever x is, but it's just cleaner and way more concise. Now, I want you to imagine you have this absolutely massive list of data, maybe thousands or even millions of usernames. How would you check if one specific username is already in that list? I mean, you could write a loop to check every single item one by one, but wow, that sounds like a lot of work.
Or you could use one of Python's most elegant and powerful operators. This one honestly feels like a little bit of magic. It is the in operator.
And the difference here is just staggering. Look, the hard way involves writing a whole complicated loop to go through every single thing. But the Python way, it's beautiful. You just ask in plain English, is the letter D in this list? Python handles all the hard work and just comes back instantly with true. It's so readable and so efficient.
So we've seen all these different kinds of operators, for math, for asking questions, for dealing with data. But when they're all mixed up in one equation, how does Python know which one to do first? Well, it turns out it has a very, very clear rulebook. And that rulebook is something you probably remember from math class, good old PEMDAS. Python follows this exact order of operations. It'll always solve things in parentheses first, then exponents, then multiplication and division, and finally addition and subtraction. It's completely predictable and reliable. And this order is what saves us from chaos. In an expression like this, PEMDAS means Python does the multiplication first, 2 times 4 is 8, and then it does the addition, 3 plus 8, which gives us the correct answer of 11. Without this rule, you might get 20 and our code would be completely unreliable. And this brings us all the way back to the core philosophy of Python itself. From that elegant in operator to the clear rules of PEMDAS, the entire language is designed around this one powerful idea. Operators aren't just tools. They're really the embodiment of this philosophy. They let us build powerful, complex logic from simple, understandable pieces, which really leaves you with one question, right? How can this focus on simplicity change the way we approach and solve problems?